Today we're going to begin section 1.4. Here we will be eliminating and solving systems in 3 variables. First, turn to page 20 of your journal and copy down the definitions. Next, read through the 3 steps of solving a 3-variable system. Now let's look at some examples. In your notes packet, you may not have enough room for example 1, so maybe do example 1 on a piece of lined paper. What I'd like you to do is first rename equations 1, 2, and 3 and name them A, B, and C. And what we're going to do first is take equations A and B, eliminate a variable, and call the new equation D. Then take equations B and C, eliminate the same variable, call that equation E. Then put D and E together and eliminate a different variable. And then you'll be able to work backwards and solve for all 3 variables. So let's look at equations A and B. So in equations A and B, we want to eliminate a variable. We could eliminate the x term. If we multiply the B equation by -2, we'll have 4 and -4, and when we add them down, they will eliminate. So let's recopy A, but multiply -2 through to the B equation. So when I add my equations down, notice the x terms drop, and I'm left with 8y minus 7z equals 26. Let's label this equation D. Now let's look at 2 new equations, B and C. For equation B and C, we want to eliminate x again. So in B we have 2x, and in C we have 6x. So let's make them both 6's. Let's make B -6, which means we have to multiply all of the B equation by -3. That will change the x term to -6x. Plus 9y minus 15z equals 21. We don't need to touch the C equation, so just recopy it. Now let's add the equations down, and notice the x term is eliminated. We're then left with 8y minus 9z equals 18. We're going to call this equation E. Now let's put equations D and E together. Looking at equations D and E, we want to eliminate a new variable. Probably y would be the easiest because we only need to multiply -1 through either equation. So let's recopy D and multiply -1 through the E equation. Now when I add the equations down, the y terms will drop out, and I'm left with 2z equals 8. I can easily now solve for z by dividing both sides by 2, and I get z is 4. You want to then work backwards. Plug z is 4 into either equation D or E, whichever one you choose. If we plug it into D, we have 8y minus 7 times 4 equals 26. Solving for y, we're going to add 28 over and divide by 8. I did notice an error before I finish, right here. -15 plus 4 should be -11. So when I multiply it by -1, it becomes positive 11. When I add down, I get 4z. And dividing by 4, I get z equals 2. So now plugging 2 into equation D, I have 8y, 2 times 7 is 14. I can add 14 to the other side, and that gives me 40 for 8y, and then divide by 8, you get y equals 5. Now I can plug both y and z to any of the equations above, A, B, or C. So if I just do A, I get 4x plus 2 times y, which is 10, plus 3 times z, which is 2, so 3 times 2 is 6, and that equals 12. Adding 10 and 6 together, I get 16. I'm going to subtract it to the 12 side and get -4, and divide both sides by 4 and get x is -1. I can then check all 3 values in any equation, and all 3 should work. Let's look at example 2. We're going to label the equations A, B, and C. Let's take the first 2 equations, and let's try and eliminate x. Since the B equation has a 5x, I'm going to want to multiply -5 to the A equation. So multiply a -5 through, and then recopy the B equation. Then I'm going to add the equations down. Notice the x terms drop out along with the y's and the z's. That leaves me with 0 equals -7. This is a false statement. False statements mean that there is no solution to the system. In example 3, after labeling a, b, and c, let's take a and b and try and eliminate a variable. We can easily eliminate the z by just adding right away. So I'm just going to recopy a and b, and when I add down, the z's already cancel. I'm left with 2x minus 2y equals negative 6. Call this equation D. Now let's take equations b and c and try and eliminate z again, which if you notice they're already opposites, so after recopying I can simply add down. After adding down, I'm going to call this equation E. I can put equations D and E together. Let's try and eliminate x by multiplying negative 3 to the D equation. I'm going to recopy the E equation. When I add down, both the x's and y's drop out, and I get 0 equals 0, which is a true statement. When you have true statements, that means you have many solutions, or infinite solutions.